Hello everyone and welcome back. My name is Mr. Cobalt and in this video we're going to go over qualitative chemical analysis. So let's get into this. So what is qualitative analysis? It's a method of systematically determining which metals are present in an unknown, and you do this through selective precipitation. So in my previous video we talked about selective precipitation and how that can be used to separate out one metal from another. And so when you use qualitative analysis, basically you're using kind of a flow chart to be able to add certain um, chemicals that are going to precipitate out certain metals and not others. And so if you are trying to determine what metals you have in a mixture, you can in a systematic way add certain things, certain substances to the mixture in order to see if something precipitates out. And if not, then you know that's a negative test for that particular ion or particular ions. And then you keep going through your process to identify what elements or what ions you have in your solution. So why is it called qualitative? Well, it's called qualitative because it's involving a quality or a kind. So basically, you're running tests not to figure out how much of the ion you have in solution, but just what kind of ion you have in there. So if you're trying to find out how much was actually in your solution, that would be a quantitative analysis. But all we want to know is if the ion is present or not. And so here I have kind of a diagram to show you like how this works. So here I have three different kinds of ions in my solution. I have a red, a blue, and a green. So these could be three different cations. And what I'm going to do is I'm going to add a precipitating agent to my solution that's going to precipitate out only one of those ions. So I add the agent, and then I have the red. The red kind of collects with the orange. I don't know if you can tell the color difference here, but my red is now in a solid form. It precipitates out because it binded with the precipitating agent that I added. And so now I can decant off the liquid. Decant means I'm just pouring the liquid such that I'm leaving behind the solid pellet on the bottom. So usually what happens is you centrifuge your tubes, you make the precipitate go to the bottom, and then it's kind of should be stuck there or it shouldn't go off with the liquid. So when I pour off the liquid, which is decanting, I'm going to leave the solid pellet behind in my tube. And now I'll have in my other tube, I'll have the liquid that'll have the other ions that are there. So now I have my other ions here. And so what I'll do is I'll add another precipitating agent to this one to see if I have a certain ion there. And if I do, it will precipitate out. It'll bind and precipitate out. And so I get the precipitate here, leaving behind. So my blue cation gets bound with the precipitating agent and leaves the green in solution. And so I go ahead and centrifuge that again, and my pellet is on the bottom, and I decant the liquid. I pour off the liquid, leaving the pellet behind. And now I have my supernatant. Supernatant is the fluid that's left behind, or that's decanted off. And so now you see that I have only my green cation left. So this is an example of qualitative analysis. So let's talk specifically about different groups of cations, different groups of metals that can be separated by uh, different precipitating agents. So here here are the possible initial cations I could have in my solution, right? So I'm given an unknown, and I'm like, okay, how do I determine what elements or what cations are in my unknown? So this is a particular method or qualitative analysis that you could follow. It's not the only one, but it is a method uh, to follow. And these different cations are broken up into groups based on how they react with certain in certain conditions, whether you can get them to precipitate when you add certain substances to them. So let's say I have my test tube, and I could have any of these ions in solution. So they're broken up into groups 1 through 5. So group 1 is the silver lead 2 ion and my mercury 1 ion. Group 2 is my copper 2, bismuth 2, cadmium, lead 2, mercury 2, arsenic, and I have antimony and tin, and then so on. So groups 3 are these metals here, group 4 and group 5. So I could have all of these mixed into my test tube. So what do? I follow a kind of flow chart and add systematically certain things to see if something precipitates. So for example, first thing I might do is add, so number 1 here, add 6 molar HCl. And so what that's going to do is this is a strong acid. It's going to dissociate completely. It's going to ionize completely in water. So I'm going to have H plus and Cl minus. And the Cl minus there is going to react. Normally it's soluble. All chlorides, or I should say most chlorides are soluble. And so this chloride ion isn't going to cause precipitation unless you've got certain cations, and that is your silver, lead 2, and mercury 1. So if you've got these in there, the chloride ion is going to bind with those and precipitate those out. So if I got a reaction, then I would centrifuge my tubes, and then the precipitate would go to the bottom, and then I would decant and remove the rest of the liquid. And then what's left over is anything from groups 2, 3, 4, and 5. So if I don't get any precipitate here, then I don't have any of these cations. So I can go to my next step. So now I've added 6 molar HCl. So now my solution is acidic after I've removed the supernatant to another tube. So now I have my second tube, and I'm going to do my next test. At this point, number 2, I would add some H2S, my hydrogen sulfide, along with possibly 0.2 molar HCl. I've already added 6 molar HCl, so I've already got acidic conditions. And what that's going to do is, since this is a weak acid, if I've already got an acidic situation here going, because of the common ion effect, it's going to drive the equilibrium to the formation of H2S. So I'm not going to have a lot of sulfide ions written out. So if I write the formula, so I'll have H2S. That's going to be in equilibrium with HS minus plus H plus. And then I have another, this is a diprotic acid, so I have my HS minus, and then that's going to ionize into S2 minus plus H plus. And so what's happening here, if I've got an acidic solution, I'm going to have a large amount of H plus, which is going to drive it towards the H2S or the HS. So I'm going to have a little bit of this, not very much of my S2, my sulfide ion. So under these conditions, I'm going to have a very tiny amount of sulfide ion in solution, And so only the metals that form sulfides, only the metals that have, I should say, let me word it this way. Only the sulfides that have a very low solubility, or say have a very low KSP value, are the ones that are going to precipitate out at this point. So the purpose of the purpose of the mercury is to the purpose of the hydrochloric acid here is to make sure it's acidic, and also make sure, therefore, that my sulfide ion concentration is very, very low. That means that only those sulfides will precipitate that have um, that have a low KSP. So all of these will precipitate out because they all have a low KSP value. Okay, so that would, if I get a precipitate at this point, then that would indicate that I have one of these, one or more of these metals here. And so I would centrifuge again, and then I would decant the supernatant into another tube, and then I would keep the pellet, and then I would move on to the next step to see, okay, what can I mix in, what can I test it with. Okay, so then number 3 here, the next step would be, okay, I can test whether I have group 3 metals in my leftover supernatant, and in this case, I'm going to add my hydroxide ion, and that does a couple of things. One, it's going to lower it's going to lower the pH. Sorry, it's going to raise the pH, lower the H plus concentration. Why do I want to do that? Well, first, if I lower the H plus concentration, that's going to cause more sulfide ions to be created. So it's going to shift towards the right, and it's going to create more sulfide ions. Raising the concentration of the sulfide ions is going to allow for those metal sulfides that have a higher KSP to then precipitate out, because in order to get them to precipitate out, you need a higher concentration of your sulfide. So we want to neutralize our acid in order to get rid of this, driving the equilibrium this way to form sulfide. Second reason is because the hydroxide ion can then combine also with some of these metals to form an insoluble hydroxide. So here, if I've got group 3 elements, then I'll either get aluminum hydroxide, iron 3 hydroxide, or chromium 3 hydroxide, or I'll get zinc sulfide, nickel 2 sulfide, cobalt 2 sulfide, manganese 2 sulfide, or iron 2 sulfide. So these will come out of solution there. So again, if I get it precipitated at this step, then I can centrifuge and then get that pellet and then decant off the rest of the liquid, the supernatant. And then what I have left could contain groups 4 and 5. So then what my next step at this point, how would I determine these metals are there? I could add ammonium hydrogen phosphate to my supernatant that's left over with some ammonia, right? And so that what that's going to do is the ammonia is going to drive the NH4 plus to keep this at a higher level. And then so what's going to happen is I'm going to create, if I have any of these barium, calcium, magnesium, I'm going to create the phosphates, some insoluble phosphates. So barium phosphate, calcium phosphates, these are insoluble. Magnesium can come out with the ammonium phosphate here. And so that way I could get rid of those. And then what's left over is going to be my group 5. And these group 5 elements do not precipitate. So my sodium, potassium, ammonium, they do not precipitate. It's very hard to get these precipitate. They just don't precipitate out. So they're going to be left in solution. You can use other ways at this point to determine whether they're there or not. You could do a flame test, right? So if you do a flame test, if you've got sodium in there, that should give a bright yellow color. If you've got potassium, that should be like a purplish violet color, and so on. So I hope this is a helpful video. This is the explanation of qualitative chemical analysis. So if you enjoyed this video, if this cleared things up, and if this helped you understand anything about qualitative chemical analysis, then please, by all means, like this video, hit that like button, subscribe to my channel, help me out. Hit that notification bell right up there so that way you can be notified by other videos I put out, and put a comment down in the comment section. Let me know what you think. If you've got any questions, I'd love to hear them. Thanks for joining me. Have a great day.